Deep within the laboratories of modern science, a quiet revolution is taking place. A revolution that could change how we think about life, death, and survival. Welcome to Beyond the Veil, where today, we dive into the cutting-edge world of artificial blood. Every year, millions of people rely on blood transfusions to survive, from accident victims to cancer patients. Yet the demand for blood often outstrips supply. Enter artificial blood, a solution that's been in the making for over half a century. But what makes creating a substitute for blood so complicated? Blood isn't just a red liquid, it's an intricate system. The oxygen-carrying red blood cells, the immune-boosting white blood cells, the clot-forming platelets, and the nutrient-rich plasma all work in harmony. Replicating even a single part of this system has been a monumental challenge for scientists. Meet Allan Doctor, a visionary leading the charge. His creation, ErythroMer, is not just another attempt at artificial blood, it's a synthetic nanoparticle designed to mimic the oxygen-carrying function of red blood cells. Quote, "What we've developed is essentially a synthetic red blood cell. It's lightweight, shelf-stable, and can be stored as a powder for years before being rehydrated for use." Unquote. This makes it ideal for emergencies and remote locations. ErythroMer works by encapsulating human hemoglobin within a synthetic membrane, creating a particle that acts much like a natural red blood cell. What's more, it eliminates the need for blood typing, making it a universal solution. Imagine a battlefield where medics can carry artificial blood in powder form ready to mix and use instantly. Or disaster zones where transporting and storing donated blood is nearly impossible. This is the promise of ErythroMer. But that's not the only breakthrough. Across the Atlantic, researchers funded by the NHS in the UK are growing blood in the lab. Using stem cells derived from donated blood, they've managed to create red blood cells that are indistinguishable from the real thing. In a groundbreaking trial, these lab-grown cells were transfused into human volunteers to test their survival and function. If successful, this approach could provide a lifeline for patients with rare blood types or conditions that make traditional donations unsuitable. Of course, this journey hasn't been without its setbacks. Earlier attempts at hemoglobin-based oxygen carriers often resulted in severe side effects, including immune reactions and cardiovascular issues. But with each failure came new insights, bringing us closer to a safer, more effective solution. The implications of artificial blood go far beyond emergencies. It could revolutionize surgery, enable long-term space missions, and even reduce the need for animal testing and research. The quest for artificial blood is more than just science. It's a story of perseverance, ingenuity, and hope. A story that reminds us how far we've come, and how much further we can go. Subscribe for more stories that unveil the mysteries of science, and remember, don't believe the hype, go beyond the veil.